So today we're adding on one little thing. It's a formula for arc length. It's S equals R times theta. S in this case is the arc length. R in this case is radius, not radians, but radius. And theta is the angle, and it has to be in radians. So the big thing about this, it's an easy formula, but the big thing is if they give you an angle that's in degrees, you got to convert it, then plug it in. So that's the only thing you got to watch for here, okay? So this would be, they might be saying find the arc length, they might be saying find theta, they might be saying find R. So you can solve for whatever's missing. So I'm going to show you a couple different ways. They could give it to you in words like this. They could say, okay, we got a circle, we got a radius of 4 inches. Find the length of the arc intercepted by a central angle of 240 degrees. You don't have to let that wordiness bother you. You're just thinking, I got a radius, I got a this, I got a that, plug in. So we're going to plug into that formula. All right, so what are we looking for in this particular problem? The arc length. Good. So we're looking for the length of, so S is what we're looking for. R, they tell us, is 4 times theta, which is 240, but we can't plug in 240 because it has to be in radians. So we're going to go over to the side and we're going to convert 240. How do I convert it? Times what? Very good. So if y'all can, all right, thank you. She's ahead of me here, but good. 4 pi thirds, she says. All right, so instead of 240, that's what we're plugging in. Again, that's the only thing you got to watch with this formula. And so S equals about 16 pi thirds, or you can hit that SD button. It is what? I'm sorry. So either one of those. I'm telling you either because if it's multiple choice and they got a decimal, you know how to get the decimal. Either way, it's good. So this is the arc length that we just found. All right, here's the thing though. That circle had a radius of 4, and they were wanting the measure that was like 240. So they were looking at this big piece right here that's 240. So you need to pay attention that you're finding that interior angle because it's the one intercepted. In other words, inside there, not the outside angle. That's important because they'll try to slip one in on you where it's the other angle. So, all right, so here's a case of where they give you just the picture. So they could say it in words, they could say it in picture. And here we're looking for theta, we're not looking for S. So same formula. S is what? 31. Radius. And we're looking for theta. So if you plug in and need to solve for theta, you need to do what from here? Divide by 12. Very good. So get theta by itself, basically. So theta will equal about 2.58. All right, 2.58. I'll stop it right there. So theta is about that much, just from dividing. Now, when you look for theta, it's automatically in radians. You don't have to put it in radians. It automatically comes out in radians. Now, y'all, again, make sure that the angle in question that they give you, in other words, if they give you a picture like this, and they tell you maybe this is 80, but they want this arc right here, you need this angle. So that's the other thing to watch for. They're not going to do it often, but they might try to slip one in. They want the angle that is inside. If they're giving you 80, but they're wanting this, I mean, just pay attention if they do anything funny like that.